Okay, today for lecture 10, we will be doing a lot of graphing. So the first thing we want to do is just review kind of what the graphing space looks like. So this is 3.1 in your book. Okay, first of all, what is the relationship between age and blood pressure? If we just look at the information given in the table, we have the age of a bunch of people and their blood pressure. Now you might not be able to tell me specifically, but in general, if I said the older someone is, then you'd say the higher their blood pressure overall. Now that we only have 8 data points there, if we had 8,000, we could still see that relationship, but it would get a little bit harder to see. Now if we look at it this way, that makes it a lot more clear. We see age along the bottom, and we see blood pressure going up the side. So you can obviously see that the older somebody is, the higher their blood pressure, and you can actually see by how much. It's kind of like they say, a picture is worth 1,000 years, 1,000 words. It just makes it easier to see relationships. You might not see specific data well, but you can see trends very easily. So what makes it easier to see the relationship? The graph does. Okay, parts of the coordinate plane. First of all, this is the x-axis. It goes horizontally. This is the y-axis, and it goes up and down. Do you remember what that point in the middle is called? That point in the middle is called the origin. Those parts most people generally remember. Here's something that people maybe don't remember, and it's not as, to be quite honest, not as vital, but it is useful in talking about points sometimes, and those are the quadrants. This is the first quadrant, and the second quadrant, the third quadrant, and the fourth quadrant. Okay, let's next look at just plotting points. So if we have points, they're going to be represented as ordered pairs. We'll have x in the first position and y in the second position. The x number tells me how far to the right or the left to go, and the y number tells me how far up and down. Now this might seem very, very easy right now, but once we start talking about slope, we're going to be doing up and down things first and then right and left things second. So just remember, if you're plotting a point, for plotting points we go right and left first and then we go up or down. So if we have these points right here, the point 5, 6 is red. So we go over 5, we start at the origin. We always start at the origin when we're plotting points. We don't start there for slope, but we will for points. So we start at the origin and go over 5 and then up 6. That would give me my red point right there. For the blue point, I have -6, so instead of going to the right 6, I'm going to go to the left 6 and then up 12. For the point 4, 10, I go to the right 4 and then down 10. Over 4, down 10, since I have -10. For -12, -15, I go to the left 12 and then I go down 15. So that gives me my purple point down there. For the point 6, 5, it's over 6, up 5. So does the order matter? If you notice, the red point and the navy blue point, they had the same numbers, but they were in different spots in the parentheses. And while they were close, they didn't necessarily need to be close, by the way, they aren't the same point. So the order does matter. That's why they're called ordered pairs. What quadrant are they in? Can you tell what quadrant that point 5, 6 is going to be in before you ever plot the point? Well, let's look at it. The 5 is positive and the 6 is positive, so I know I'm going to be going to the right and then I'm going to be going up, so it's going to be in quadrant 1. Now for the blue point, I know I'm going to go to the left and then up, so I know it's going to be in quadrant 2. For the green point, I'm going to the right and then down, so it's going to be quadrant 4. For the purple, I'm going to the left, I'm going back and then down, so I know it'll be in quadrant 3. And the navy blue point, I go up and I go right, so it will be in quadrant 1. What are the coordinates of that yellow point right there? Well, for the yellow point, I know that I'm going left and right first. So I go left 8, so that gives me -8. And then I go up 2, so that gives me the point -8, 2. All right, so now let's just look at getting useful information out of the graph. You'll see graphs all the time, like in the Wall Street Journal or just any newspaper. And they are there for a reason because, like we said before, pictures convey information a lot more concisely. So let's try to get picture information out of this picture. Okay, so these are Apple sales in US billions. We have time along the x-axis, and we have their earnings along the y-axis. When did Apple have its lowest sales? So we're going to be looking at the points that are the lowest y values, and that would be that point and that point, those two red points. So those years would be 2001 and 2002. When did Apple have its highest sales? Well, the highest number for what we've got is 2008. Obviously, as time moves forward, it's probably going up and up, at least given current trends, but that would be 2008. Were sales ever static? Static meaning unchanging. So do we have any flat areas in the graph? Well, we've got a flat area right here and right here. So between 1998 and 1999, and between 2001 and 2002. When were sales decreasing? So I'm looking for when the y values are moving down. So in this area they're moving down, in this area they're moving down, and in that area they're moving down. So if we look at the years, that would be 1991 to 1993, 1995 to 1998, and 2000 and 2001. What were sales in 1996? Well, we'll go over to 1996 and we'll go up to find the data point. Then we'll track it back, as that 10 is actually sales in billions according to the title of the slide. We have $10 billion. When did Apple have sales of $8 billion? So now we're going to look at what y equals 8. We're looking for the sales. So y equals 8, that would be anything that intersects that pink line. So we'd have 1991, 2000, and 2004. So that's just getting information out of the graph. You have a problem like this in your homework where you're just looking at average annual rainfall in Salt Lake, but the questions are very similar. Okay, now linear equations will be the next section. We will do that in the next part of this video.